to the next lecture of the subject of electric circuits. In last lecture we have discussed the theory of Thevenin's theorem and some numericals, and in the tutorial lecture we have discussed one numerical on superposition and one numerical on Thevenin's theorem. In today's lecture we are going to see next theorem in the network analysis, that is Norton's theorem. Norton theorem वरती आपण एक बघणार आहोत question. So question in the Norton theorems will come in your examination for either 4 marks or 2 marks. That is if the question is like that state Norton's theorem or give statement for Norton's theorem, then that question will be for 2 marks. And if the question is given in this format, state Norton's theorem and give the steps to develop the Norton's equivalent circuit from Thevenin's theorem, or state and explain Norton's theorem, then this type of question will ask in examination for 4 marks. So today we are going to see Norton's theorem, and we are also going to discuss that how Thevenin's and Norton's theorems are equivalent. So before understanding the equivalence, first we will discuss the concept of Norton's theorem. So to discuss the concept of Norton's theorem, first of all we should understand Thevenin's theorem. Statement of Thevenin's theorem should be understood. Okay, so the statement of Thevenin's theorem we will revise it today, and then we will discuss the Norton's theorem. So this is the statement that any network containing active or passive element and or one or more dependent source can be replaced by equivalent network containing a voltage source and series resistance. Means in Thevenin's theorem, the current which we have to calculate through any branch is replaced by the voltage source, that is Thevenin's equivalent voltage, and a series resistance called as Thevenin's equivalent resistance. म्हणजे Thevenin's theorem मध्ये आपण बघणार होतो की ज्या ब्रँचच्या अक्रॉस आपल्याला करंट कॅल्क्युलेट करायचा आहे त्याच्यासाठी आपण त्या ब्रँचला आपण रिप्लेस करत होतो किंवा त्या ब्रँचला आपण ओपन सर्किट व्होल्टेज VOC किंवा Thevenin's equivalent व्होल्टेज म्हणतो आपण त्याला VTH, तो आणि एक सिरीज रेजिस्टन्स ज्याला आपण Thevenin's रेजिस्टन्स RTH म्हणत होतो, तो आपण त्या रेजिस्टन्सला कनेक्ट करत होतो आणि मग आपण करंट फाइंड आउट करत होतो using Thevenin's theorem. Similar concept will be applied in the Norton's theorem, but in Thevenin's theorem the network containing or active passive network was replaced by an equivalent network containing a voltage source and series resistance. This wording is most important. These two words are most important. In Thevenin's theorem, there is one voltage source and a series resistance, but in Norton's theorem, there is current source and resistance in parallel with the current source. Voltage source आणि series resistance हे Thevenin's मध्ये होतं, तर Norton's theorem मध्ये तुम्हाला करंट सोर्स आणि Norton's equivalent resistance होता, जो की त्या करंट सोर्सच्या पॅरलल मध्ये आहे. इथे तुम्हाला ही डायग्राम लक्षात येईल. In Thevenin's theorem, we was having open circuit voltage of VOC So this is your Thevenin circuit. So here in the left side I have drawn the Thevenin's equivalent circuit. In Thevenin's equivalent circuit, this was VTH, that is a voltage source, and this was your RTH, that is series resistance or Thevenin's equivalent resistance. But in Norton's theorem, this voltage source is replaced by current source and parallel series resistance is connected in parallel nature. इथे बघा थेव्हनिन्स रेजिस्टन्स हा पॅरलल मध्ये गेला आणि थेव्हनिन्स व्होल्टेजच्या ऐवजी नॉर्टन्स मध्ये तिथे आपण करंट सोर्स घेतलाय. Hence this Norton's theorem is called as dual of the Thevenin's theorem. Norton's theorem is called as dual of Thevenin's theorem. Because in Norton's theorem we are replacing a current source instead of voltage source. Instead of voltage source we are using a current source. We are replacing the voltage source by current source in Thevenin's equivalent circuit. In Thevenin's equivalent circuit. Or simply we can say we are transforming the Thevenin circuit into Norton circuit by using source transformation. Source transformation means what? We are transforming the current source into voltage source or voltage source into current source. So here we are transforming the voltage source of the Thevenin's equivalent network into current source for Norton's theorem. Norton theorem साठी आपण सोर्स ट्रान्सफॉर्मेशन करत होतो, म्हणजे इथं थेव्हनिन्स नेटवर्क मधला व्होल्टेज सोर्स नॉर्टन्स मध्ये आपण करंट सोर्स नी ट्रान्सफॉर्म केलेला आहे. हेन्स इट इज कॉल्ड एज ड्युअल ऑफ थेव्हनिन्स theorem. Norton's theorem is called as dual of Thevenin's theorem. And here we are performing the source transformation from voltage to current source. So now we will focus on the statement of the Norton's theorem, most important part of this theorem, because they are compulsorily in examination on this chapter a statement for any theorem, for superposition, Thevenin's, Norton's or MPPT, that is maximum power transfer theorem. For all these four theorems either numerical or statement are questioned in the examination. परीक्षेमध्ये या चारही theorems वरती तुम्हाला न्यूमरिकल किंवा स्टेटमेंट हे येतातच. If statement of superposition theorem is asked, then there will be numerical on Thevenin's, there may be numerical on Thevenin's. If statement on Norton's is asked, then there will be numerical on maximum power transfer or vice versa. That means if theorem of Thevenin is asked, then numerical on superposition. If theorem of maximum power transfer is asked, numerical on Norton's theorem. So this chapter is most important chapter for studying the subject of electric circuits and networks. Hence I am insisting on the statement of these theorems. You also pause your video, write down the statement for Norton's theorem and try to recite, try to by heart the statement, because the statement is the most important for all the theorems in this chapter, not only Norton's but for superposition, Thevenin's and Norton's and maximum power transfer. So now we will move towards our statement of the Norton's theorem. So what is the statement? A statement is mentioned that any linear active resistive network containing one or more voltage and or current sources can be replaced by an equivalent circuit containing a current source called Norton's equivalent current ISC and equivalent resistance in parallel. Try to remember the statement of Thevenin's theorem. In Thevenin's theorem we were writing that any linear network containing one or more voltage or current source can be replaced by Thevenin's equivalent voltage VTH and a series resistance called as Thevenin's equivalent resistance. This was the statement for Thevenin's theorem. Similar statement will be for Norton's theorem, but the wording will change with the current source and equivalent resistance in parallel. So if you by-hearted the statement of Thevenin's theorem, then you need not do the by-hearting of Norton's theorem, but just you replace the wording voltage source by current source and series resistance by parallel resistance. That will make the statement of Norton's theorem. That will make the statement of Norton's theorem. याच्यामध्ये थेवेनिन्स थेरम जर तुम्ही पाठ केला असेल, बाय हार्ट केला असेल, देन तुम्हाला इथे नॉर्टन्स थेरम पाठ करायची गरज नाहीये. थेवेनिन्स मध्येच फक्त व्होल्टेज सोर्स ऐवजी करंट सोर्स लिहायचा आणि सिरीज रेझिस्टन्स ऐवजी पॅरलल रेझिस्टन्स लिहायचा. तो तुम्हाला नॉर्टन्स थेरमचा स्टेटमेंट तयार होईल. इथे तुम्हाला नॉर्टन थेरमचं स्टेटमेंट तयार होतो. So this is the statement of Norton's theorem. So what is the statement? Any linear active resistive network containing one or more voltage source and or current source can be replaced by an equivalent circuit containing current source called Norton's equivalent current and equivalent resistance in parallel. This is the statement of Norton's theorem. Okay. Now we will see the Norton's equivalent circuit here. This is the figure number B shows you the Norton's equivalent circuit. Here a current source is there, ISC, or I can also write it as IN. In some book, in some numericals, this current source is also mentioned as IN, that is Norton's equivalent current source. And this is RN or R equivalent is equals to RTH. Okay, this is your Norton's equivalent theorem. We will discuss the steps to how to solve the Norton's theorem. Then we will discuss the equivalence for Thevenin's theorem. दिलेलं नॉर्टन थेरमनी कसं सॉल्व्ह करायचं, दिलेलं सर्किट नॉर्टन थेरम्सनी कसं सॉल्व्ह करायचं त्याचे स्टेप्स आपण सगळ्यात पहिल्यांदा अंडरस्टँड करून घेऊया. ओके, फॉर एक्झाम्पल दिस इज अ सर्किट. If this is a given circuit, let us consider a circuit is given in this manner. Here is one voltage source and here is another voltage source. And these resistances are having the value R1, R2 and R3. And we have to solve this circuit using Norton's theorem. Okay, for example, just consider, and this is the voltage source V1, this is the voltage source V2, and now we have to calculate or we have to find out the current, for example, flowing through this R2 using Norton's theorem. So how to find out that current flowing through R2 resistance through current कसं find out करायचं आहे? For this we are going to see first of all the steps for solving the given circuit using Norton's theorem. So your first step is short circuit the required branch and calculate the short circuit current ISC by using Kirchhoff's law. That means if you are going to calculate the current through R2, first of all we have to short circuit this. म्हणजे हा रेझिस्टन्स काढायचा आहे अँड यू हॅव टू शॉर्ट सर्किट दॅट branch. Okay, so first of all we have to short circuit the required branch and calculate the short circuit current using Kirchhoff's law. Then Kirchhoff's voltage law, current law, what is applicable there? By using that Kirchhoff's law you have to calculate the short circuit current. Then we have to calculate the Thevenin's equivalent resistance or Norton's resistance for this circuit. The procedure will be similar like Thevenin's theorem. Thevenin's theorem ला जशी सिमिलर प्रोसिजर होती त्या प्रकारे आपण इथे कॅल्क्युलेट करणार आहोत. फक्त थेव्हिनिन्स मध्ये व्होल्टेज सोर्स होता, इथे मात्र आपल्याला करंट सोर्स फाइंड आउट करायचा आहे. थेव्हिनिन्स मध्ये आपण थेव्हिनिन्स इक्विव्हॅलेंट व्होल्टेज व्हीटीएच फाइंड आउट करत होतो, इथे आपल्याला शॉर्ट सर्किट करंट आयएससी किंवा आयएन फाइंड आउट करायचा. इन Thevenin's theorem we were calculating the Thevenin's voltage, but in Norton's theorem we have to calculate the short circuit current or Norton's current IN. Okay, so we have short circuited the required branch and calculated the short circuit current. Then calculate Thevenin's equivalent resistance or Norton resistance RN, and then the third step, similar to Thevenin's theorem, we have to draw the Norton's equivalent circuit and calculate the current through the required branch by the given formula of I is equals to ISC into R equivalent divided by R equivalent plus RL, where R equivalent is nothing but your Thevenin's equivalent resistance or Norton's resistance. ISC is nothing but your Norton's circuit current, and RL is the resistance through which we are going to calculate the current. So this is the steps for Norton's theorem. Now if you remember, similar step will occur for the Thevenin's theorem, but as I told you, in Thevenin's theorem we are calculating the open circuit voltage. In Norton's theorem we are calculating the short circuit current. This is the difference between Thevenin's and Norton's theorem. Okay, I hope you must have understood the steps for Norton's theorem. Now how to calculate that RTH or RN, that is Thevenin's equivalent resistance or Norton's resistance RN, how to calculate it. So here I have mentioned the step that how to calculate it. So to calculate Norton's resistance RN, we have to first make all our voltage sources zero. But how to make zero? If the source is a voltage source, replace it with short circuit, and if the current source is there, then replace it by open circuit. Similar to the superposition theorem. In superposition theorem or in Thevenin's theorem, what we were doing? In both the theorems, the voltage source we were replacing by short circuit and the current source we were replacing by open circuit. So same procedure here we have to do. Firstly, first step to calculate the RN or RTH or R equivalent. This RN is nothing but your RTH, Thevenin's equivalent resistance. To calculate this, similar procedure we are doing. Okay, then find the resultant resistance between the two marked terminals. Whatever terminals we have marked, whatever current we are finding between the two marks, so we have to find out the resistance for the given circuit between that two terminals, 2 points. And hence whatever resistance we are getting, that is RN is equals to RTH. Okay, means if you have calculated the Thevenin's resistance RTH, Thevenin's resistance RTH जर तुम्ही calculate केलं, that Thevenin's resistance is equivalent to Norton circuit. म्हणजे इथे एक बेनिफिट आहे बघा. If in examination a question occurs that solve the given circuit by using network theorems, then it is beneficial for you. You can either use Thevenin's or you can either use Norton. because both will be similar, just a difference will occur in the sources. In Thevenin's theorem we are using open circuit voltage, in Norton's theorem we are using the short circuit current. But whatever value of resistance you are calculating in the Thevenin's equivalent circuit, same value will occur in the Norton circuit. Same value will occur in the Norton circuit. So this is a plus point, that Norton's theorem is dual of Thevenin's theorem. Okay. So in this manner we are calculating our Norton's resistance. Now how to calculate short circuit current or Norton's current? So to calculate the short circuit current or Norton's current, first of all we have to short circuit the sources or short circuit the current between the marked terminals. Means, as I have told you, in this I had to find out resistance R2, so I have short circuited the branch by replacing the R2 with short circuit. शॉर्ट सर्किट करायचं असेल तर रेजिस्टन्स काढायचं आणि तिथं शॉर्ट सर्किट कनेक्शन करून टाकायचं, अँड दॅट करंट विल बी युअर शॉर्ट सर्किट करंट ISC or IN. ISC or IN. When we will discuss the numerical on Norton's theorem, you will understand that which current is called as Norton's current or short circuit current. And lastly, we are drawing the Norton's equivalent circuit similar to the Thevenin's equivalent circuit by replacing the previously removed circuit between the terminals of equivalent circuit. Replacing previously removed circuit between the terminals of equivalent circuit. As like Thevenin's theorem, we were using the voltage source VOC, Thevenin's resistance RTH and RL. In Thevenin's theorem, we were using this source of VOC, then Thevenin's resistance RTH and the load resistance. So this was your Thevenin's equivalent circuit. This is your VOC. This is your RTH. And this was your load resistance RL. Similar manner, your in Norton circuit, here a current source will come, that is called ISC. Then Norton's resistance RN, and then your load resistance RL. So this was your Norton's equivalent circuit. This is your RL, that is the branch through which we have to calculate the current. This is your RN or RTH you can say, and this is your short circuit current or Thevenin's current IN or ISC. Okay, so in this manner we are going to calculate the current flowing through the load resistance. So here in this circuit you can understand the Thevenin's equivalent circuit is shown here in figure B, and in figure C a Norton's equivalent circuit is there and formula is shown to you. In Thevenin circuit we are using formula VOC divided by RTH plus RL, and here in Norton's equivalent circuit it becomes RTH into ISC divided by RL plus RTH. How this is, see here, by this formula current can be calculated as V by R, that is short circuit current ISC is equals to VOC divided by RTH, and therefore VOC is equals to ISC into RTH. Replacing this value in this Thevenin's equivalent voltage, you will get Norton's equivalent current. Thevenin's equivalent च्या करंटच्या फॉर्म्युला मध्ये आपण VOC ची व्हॅल्यू रिप्लेस केली ISC into RTH नी, आणि मग आपल्याला नॉर्टन्स इक्विव्हॅलंट करंट मिळतो. So this is the equivalence between Thevenin's and Norton's theorem. That means you can find out the current flowing through any circuit either using Norton's or Thevenin's theorem. If you have find out you have analyzed the circuit using Thevenin's theorem, then also after this stage, at this stage, that is I is equals to VOC divided by RTH plus RL, you can replace this formula by Norton's equivalent circuit, and then you will get the current through Norton's theorem. You can get the current through Norton's theorem. So this is the equivalence between Thevenin's and Norton's theorem. So if you are finding the current through the given circuit using Thevenin's theorem, and then you are using a step of Norton's equivalent circuit, then these are the steps that by these steps you can find out the given circuit using Norton's theorem and Thevenin's theorem. Thevenin's theorem आणि Norton's theorem चा यूज करून तुम्ही कशा प्रकारे एखादं सर्किट सॉल्व्ह करू शकतात ही स्टेप आहे. फर्स्ट ऑफ ऑल, calculate open circuit voltage and Thevenin's resistance, then find out the value of short circuit current, that is ISC is equals to VOC divided by RTH. Whatever RTH you are getting, that is your equivalent resistance or Norton's resistance, and then draw the Norton's equivalent circuit and find out the current. So this is the method to calculate the given circuit using Norton's theorem by incorporating Thevenin's theorem. ही स्टेप आहे तुमचा एखाद्या सर्किटचा करंट नॉर्टन थिअरमनी फाइंड आउट करायचा, पण थेवेनिन थिअरमचा यूज घेऊन विथ द हेल्प ऑफ थेवेनिन्स थिअरम. ही स्टेप पण आपण यूज करू शकतो. हाऊ टू फाइंड आउट दॅट वी विल सी इन द न्यूमरिकल, that will make you understand that how to calculate that current using Thevenin's theorem. The application of Norton's theorem we can discuss is that Norton theorems make it possible to convert the complicated network to simple equivalent network. So using the voltage, current and power delivered to the load, we can make a complex network, complex circuit into a simple circuit using network theorem. This is the major application of Norton's theorem. I hope you must have understood the Norton's theorem. Compare this theorem with the Thevenin's theorem, and if a question arises in the examination that distinguish between Thevenin's theorem and Norton's theorem, so your first point for distinguish will be statement of both the theorems. Second point will be, in Thevenin's theorem we are calculating open circuit voltage, in Norton's theorem we are calculating short circuit current. So these are the 2 points for the distinguish between Thevenin's theorem and Norton's theorem. There may be a question in examination for 2 marks, so you could write down the answer for this with these 2 points. Okay, so a homework with this question is that write down the question for your homework, that is distinguish between Thevenin's theorem and Norton's theorem. Thevenin's theorem and Norton's theorem. So this is a question for your homework. You should write down the answer for the distinguish between points and send me the answer on the WhatsApp. Till tomorrow, till today 5 p.m. Today means on the date of 28th December 2020, till 5 p.m. you can send me the answers for the given question, that is distinguish between Thevenin's theorem and Norton's theorem. So you yourself compare the theorem, find out the difference between both the theorems and write down the answer, because there may be a question in the examination that distinguish between Thevenin's and Norton's theorem. And also with this question write down another question that state Thevenin's theorem and state Norton's theorem. So these three questions. What three questions? First one is distinguish between Thevenin's theorem and Norton's theorem. Second question is state Thevenin's theorem. Third question is state Norton's theorem. These three questions you should send me on WhatsApp till 5 PM today itself. Okay, so we will stop here. Thank you.